very good evening and good days to my esteemed supervisor, Dr. Tiong Wei King, and my honorable examiners. So today I am going to present my final year project 1 titled Home Interior Designing Application using XR Headset. Allow me to introduce myself first. My name is Felix Noell Nuing, anak Tero, matrix number 73459 from Bachelor of Computer Science and Technology of Multimedia Computing. So for this presentation, we will discuss on 3 sections. So for the first section, we have chapter 1, we will discuss on the introduction. The second one, chapter 2, the literature review, and lastly, chapter 3, methodology. Introduction of this project. So, the rapid advancement of augmented reality AR and mixed reality MR has introduced immersive way to visualize digital content within physical surrounding, offering potential for the interior design industry. Traditional visualization methods, such as 2D and 3D static rendering, often fail to convey realistic proportion and spatial arrangement, leading to challenges for homeowner attempting to imagine furniture layout and for designer trying to communicate ideas to client. To address this limitation, this project leveraged the growth of XR technology to develop an interactive mixed reality application for XR headset. The application aims to provide a more engaging and accurate experience by allowing users to interact with virtual furniture model directly within their real-world environment. Before we dive deeper into the presentation, it is important to understand the current challenges faced by homeowners. My research identifies several critical issues in the traditional interior design process. So for the first one, visualization struggle. First-time homeowners often find it difficult to accurately imagine how new furniture will fit within their new specific home environment. Secondly, it will cause a costly error. This lack of visualization frequently leads to the purchase of furniture that is the wrong size, color, and design. Thirdly, communication gap. Designers struggle to convey complex ideas to clients who may not be able to interpret traditional 2D floor plan. Fourth, technical limitation. Conventional 2D layouts and static images fail to provide a realistic sense of space, depth, and proportion. And lastly, customer dissatisfaction. The final physical setup often fails to meet the client or homeowner original expectation and requirement. Next, we will discuss on the project scope. The first scope of this project is the primary hardware. The project focuses on designing and developing an interior designing application specifically for XR headset. Secondly, core interactions. User will be able to place, move, and scale 3D furniture model directly within their physical environment to improve spatial understanding. Thirdly, development framework. The application involves building a user-friendly interface, integrating AR function, and implementing controls via the XR interaction toolkit. Fourth, demonstration asset. The scope includes a curated set of 3D furniture model to be used for testing and demonstration purposes. And lastly, spatial accuracy. The application aims to provide better spatial perception by allowing virtual objects to exist at a one-to-one scale within the user real-world room. Aims and objective. The first objective is to design a mixed reality application for interior design visualization by considering factors such as spatial accuracy, hardware limitations, and ease of use. Secondly, to develop the application using Unity and XR interaction toolkits to support real-time furniture placement and manipulation. Lastly, to evaluate the usability and functionality of the proposed application. The brief methodology of this project. This project will adopt the Agile methodology, focusing on iterative development, continuous user feedback, and rapid adaptation to the requirement. Firstly, we have the planning phase. Define the primary project goal and target user. Identify core features like furniture placement and specify hardware software requirements. Secondly, requirement analysis. Gather and refine detailed functional requirements. Research compatible XR devices and 3D furniture models while designing system architecture and UI UX wireframe. Thirdly, design phase. Map interaction flow for intuitive furniture manipulation and create high fidelity AR visualization architecture. Plan the 3D environment and develop UI prototypes for a smooth user experience. Fourth, implementation phase. Develop the application using Unity 3D, C# and the XR interaction toolkit. Integrate core function like spatial mapping, object placement, and user customization feature. Fifth one, testing phase. Conduct ongoing tests for functionality, usability, and stability with small user group throughout the process. Address feedback and identify issue through mini iteration. 6. Deployment phase. Release the prototype to XR headset for real-world evaluation. Test for accuracy and responsiveness in physical environment to identify areas for improvement. And lastly, the seventh one, back to planning. Utilize information and user feedback to inform the next development sprint. Repeat the cycle until application meets all performance, usability, and functionality goals. Significance of this project. Firstly, enhance visualization. This will enhance the experience for homeowner and designer by allowing for effective planning and visualization of interior spaces. Secondly, bridging the gap. Integrate AR technology to bridge the gap between imagination and reality, improving spatial understanding of furniture arrangement in home designing. Thirdly, improve communication. Strengthen the communication level between designer and client by providing a shared realistic view of the design. And lastly, XR technology growth. It will support the growth and implementation of XR technology in Malaysia beyond entertainment sector, specifically in fields like education, designing, medicine, and architecture. Moving on to the project timeline, this Gantt chart illustrates the 14-week schedule for the final year project 1. The project was initiated in late September with topic selection and supervisor matching, followed by a month-long phase dedicated to the project proposal. As you can see here, the most significant portion of the time was allocated to Chapter 2 and Chapter 3. This allowed me to conduct a deep dive into the XR hardware comparison and technical architecture. We are currently in the final week of the schedule, focused on the submission of this final report and presentation. And finally, expected project outcome. Firstly, interactive experience. Enable user to interact naturally with virtual 3D models using an XR headset. Secondly, functional AR application. A fully operational AR interior design application capable of visualizing virtual furniture in real-world environments. Thirdly, technical feature. Include an intuitive user interface, accurate spatial mapping of the physical room, and high-fidelity rendering of furniture assets. Fourth, technology demonstration. Successfully demonstrate the practical potential of MR technology within the modern interior designing industry. And lastly, enhance planning. Significantly improve the user experience for homeowner during the design and spatial planning process. Let us proceed with the second section of this presentation, which is Chapter 2, Literature Review. Introduction of this section. So the literature review chapter established the theoretical and practical foundation for the proposed mixed reality MR application by examining existing research and technologies in interior designing visualization. It evaluates the core concept of extended reality XR, explore technical specification of current hardware, and review existing system to identify the research gap that justify the need for an XR headset-based solution. So, a brief introduction of extended reality. Extended reality serves as an umbrella term that encompasses augmented reality AR, virtual reality VR, and mixed reality MR. While AR overlay digital objects on the real world and VR create fully virtual environment, mixed reality MR combine these elements to allow user to interact with virtual object within the actual physical context. This makes MR uniquely suited for interior designing, as it provides the realistic spatial understanding and interactive furniture manipulation necessary for effective home planning. Let us dive deeper and explore different options of XR hardware available in the market for consumer use. So firstly, we have the Meta Quest 3, developed by Facebook, aka Meta, a standalone MR headset featuring high-resolution color pass-through and robust spatial mapping. Its strength including superior object occlusion and spatial awareness, but it is physically bulky and can suffer from visual noise and graininess since user is looking at video feed. Secondly, we have Virtual Pro XR, a standard AR glasses. It is lightweight and highly portable glasses primarily designed for entertainment. Even though affordable, it lacks of 6 degree of freedom tracking feature, meaning virtual furniture cannot be fixed in a specific spot as the user move. This is more suitable for watching movie or playing games. And lastly, we have Future Luma Ultra. It is a high-end XR glasses. So this hardware is selected as the primary hardware for this project, since these glasses offer 6 degree of freedom support and hand gesture control in sunglasses form factor. They provide the ideal balance of portability and optical see-through, allowing user to see their real environment naturally rather than through a camera feed. Augmented reality in interior design. Augmented reality (AR) is a transformative tool that bridges the gap between 2D planning and 3D visualization in both education and professional practice. In educational setting, it enhances spatial perception and learning effectiveness by allowing students to visualize complex layout in real time. Commercially, AR acts as a powerful try before you buy mechanism used by retailers such as IKEA to reduce customer uncertainty and increase purchase intention. It also facilitates remote collaboration, enabling designers to virtually visit and modify client living spaces. However, traditional mobile-based AR is limited by poor occlusion, virtual object floating on top of real one, limited interactivity, and scale perception issue caused by viewing object through a small 2D screen. This drawback emphasizes the need for mixed reality on dedicated headset to provide superior depth sensing, hand tracking, and environmental understanding. Next, we will review on existing system currently available in the market. Firstly, we have Arkeo. Overview. It is built specifically for VR/MR, targeting architects and urban planner. The core feature, it has volumetric modeling, function as a sculpting studio rather than a simple asset placer. The strength of this system is it supports real-time collaboration, and secondly, it supports pass-through. And the weakness of this system is it has a high connective load, which could be a barrier for average homeowner. And then secondly, it has a visual fidelity whereby to maintain high performance on mobile chipset, it uses a flat shaded graphic rather than a photorealistic material. Next, we have IKEA Creative, a consumer-facing AR tool embedded in the IKEA mobile app. The core feature of this system is it has AI scene scanner. It uses AI to erase existing furniture in a room so user can start with an empty room. And then the strength of this system is it is highly accessible. It is available in iOS and also Android. And then it also has integration with the catalog from IKEA themselves. So user can browse through the furniture in the catalog. And then the weakness of this system, the keyhole effect. User view the room through a small screen. It will provide a restricted field of view compared to the immersion of a headset. And then secondly, ergonomic fatigue. Since user need to hold a phone at eye level for a long period of time, this could lead to physical exhaustion. And next, we have Planner 5D. This system bridges the gap between casual game like The Sim and serious design. The core feature of this system is it has a bifurcated workflow. It separates 2D blueprint planning from 3D visualization. So user can design in 2D blueprint and then user can switch to 3D camera and they can walk through the space. And then the strength of this system is it has intuitive UI. So user can simply drag and drop the furniture asset in the working space, which is a very simple mechanism. And then it also offers an extensive library, thousands of assets user can choose from. And then we have the weakness. Sometimes this system might experience performance lag because it struggles with high polygon furniture. And then lastly, unfortunately, this system it has paywall. So high quality photorealistic render, ray tracing, they put it behind paywall. So user need to pay in order to see a more realistic furniture. And lastly, we have Shape XR. This system functions as Figma for team to mock up idea. So the core feature of this system is it has a low fidelity mockup. It uses simple primitive shape to test spatial flow like sphere or cube. So the strength of this system is the UX testing. It excels at validating physical clearance. So for example, a user can place a virtual table and a wall, and then user can try to physically walk through the space if they can walk through it. And then the secondly is real-time collaboration. Just like Archeo, it supports real-time collaboration between multiple users so they can work on the system together. And then the weakness of this system is it has low visual fidelity. So since this is for mockup, so they just use a very simple polygon. And then lastly, it has a high complexity, which is not suitable for average homeowner. And now we move forward to the development tool of this project. Firstly, we discuss on the engine and the framework. So for this project, we will use Unity game engine as our main engine because it has a robust cross-platform ability. And then secondly, we will use universal render pipeline. It is important to maintain high frame rate and high fidelity graphic on mobile device to prevent motion sickness. And then we will use C# scripting for implementing application logic such as including furniture instantiation and UI state management. And then lastly, the XR Interaction Toolkit XRI, a high-level system that standardizes interaction, allowing for both hand tracking and physical control inputs within the same code base. And next on development tool for spatial mapping and compatibility, this application need AR foundation to manage mixed reality feature, specifically the pass-through API, which overlay digital content onto the real world. And then it also need to have plane detection. It is essential for identifying physical floor and wall to ensure virtual furniture is placed accurately. And then it also need to have open XR plugin and industry standard that ensure broad compatibility across device like Meta Quest 3 and virtual XR glasses. And now we discuss on the design and optimization pipeline. So we will use Blender. It is a 3D modeling utilized for creating and optimizing the furniture asset. And then we have asset optimization, essential for decimation to reduce the polygon count, and texture baking to ensure smooth performance on limited mobile processor. And then we will also use Figma, used for designing wireframe and interaction flow. And lastly, user-centric approach. Interface layout are validated in Figma for usability before implementation, aligning with the agile methodology. Based on existing system and also hardware, there are some failure of current option. So the problem is the market is polarized with options such as accessible but limited mobile app and also powerful but too complex professional AR. So the goal is to find a solution which offer professional grade immersion with consumer friendly level. And now we will discuss on the limitation of mobile AR. Firstly, keyhole effect. This effect happens when small phone screen is used. When designing, it will provide a narrow field of view, which could be challenging and lower the user understanding of the furniture placement in the space. And then secondly, we have gorilla arm fatigue. When user holding a phone for too long when designing, it will cause physical exhaustion. And then thirdly, lack of depth. Relying on 2D screen remove binocular disparity, making it harder to judge through scale. And then finally, extra effect. Poor occlusion will cause the virtual furniture to be floating on top of real object, breaking the illusion of reality. And as you can see here, this is an example of gorilla arm fatigue. The user is raising his arm for a long period of time playing video game in VR headset. So this action is unnatural for human body. So he will experience the gorilla arm fatigue if he kept this posture in long period of time. And next, we will discuss on the limitation of professional VR. So the user is isolated from the reality. The VR headset, such as MetaQuest 3, separate the user from the real world, isolating them, which could block real world lighting and color. And secondly, the comfort barrier. Devices such as MetaQuest 3, it is very heavy and bulky, which is not suitable for casual owner. And speaking from my own experience, when I try out the MetaQuest 3 for the very first time, it is very disorienting and straining my eye. Based on our earlier discussion about the limitation of mobile AR and also professional VR, I propose a solution whereby we use an optical see-through XR glasses. So there are a few reasons why. Firstly, natural vision. Unlike video pass-through, OST glasses allow users to see their real world through transparent lenses, ensure to achieve a more accurate color and lighting. And then secondly, wearability. The glasses is lightweight and keeps hand-free for interaction with the virtual furniture. However, we will face a challenge whereby a ghosting challenge. So in order to solve this, so XR glasses offer electronic dimming, which allow the lens to tint electronically, ensuring virtual furniture look solid in bright rooms. And lastly, I will present the last section for this presentation, which is Chapter 3, Methodology. As per our discussion earlier in Chapter 1 for brief methodology, we are using agile approach, focusing on continuous improvement and user feedback. The first one is planning phase, creating goals and hardware compatibility. Second one, requirement analysis, gather functional needs such as furniture scaling, chosen hardware, and AR mode for the hardware. Third one, design phase. We will use Figma for prototyping and UI UX flow. The fourth one, implementation phase. So this is the actual construction of the project by coding the application in Unity using C# programming with XR interaction toolkit for complex interaction. And for 3D asset will be prepared in Blender are imported into the project. Fifth one is the testing phase. So testing the application with target user and take note for any feedback, improvement, and issue regarding on the project. And sixth one is deployment phase. We will release the prototype to XR headset for real-world evaluation. Test for accuracy and responsiveness in physical environment to identify areas for improvement. And lastly, back to planning. Go back to planning if there are issues arise during the testing and deployment for debugging and refinement. Moving forward to the hardware requirement of this project. So for this project, it need to have a high performance workstation with RTX 3060 GPU and 16 gig of RAM for 3D rendering and XR simulation. And then the second one, for the main device, we will use virtual XR glasses, the Luma Ultra, featuring micro OLED panels with 1080p and 120 refresh rate to prevent motion sickness. And the input, we will use any compatible controller or hand gesture as pointer for interaction. And next is software requirement. So for the engine, we will use Unity with Universal Render Pipeline URP for high fidelity mobile graphic. And for handling the logic, we will use C# programming for furniture instantiation and UI navigation. And then for the framework, we will use AR Foundation and OpenXR for pass-through API and plan detection. And lastly, for asset, we will use Blender for model optimization and Figma for interface wireframing. And now we will discuss on the system requirement. Firstly, the functional requirement. It need to have a spatial mapping whereby it will scan room for accurate placement. And then the interaction need to have selecting, moving, rotating, and scaling the 3D model. And then thirdly, spatial UI, a floating menu anchored to the user view. And then secondly, for the non-functional requirement, so for the performance, you need to maintain 60 to 72 FPS for visual comfort. And then for the stability, you need to ensure virtual object remain anchored without drifting. And lastly, you need to be ergonomic to minimize gorilla arm syndrome through efficient short duration gesture. And now I will present on the system modeling of this application. So for this application, we will use unified modeling language to represent the structure. So firstly, we have the actor. So the primary actor is the user. So in this case is homeowner. So for the use case, it cover environment scanning, catalog browsing, extend with filter category, and then furniture placement, and lastly manipulation. So for manipulate furniture, it will include moving, rotating, scaling, and also delete. And now we move forward to the activity diagram. So this is to represent the flow of the application. So firstly, the initialization. So the process begin by initializing XR sensor and entering a scanning phase to map the physical environment. Secondly, spatial validation. A decision node checks if a flaw is detected or not. If not, the system prompts the user to move their head for more data. Third, interaction readiness. Once validated, a visual placement grid appears, signaling that the system is ready for use. Fourth, main application loop. The user browses the 3D catalog, select a model, and place it onto the detected flaw. Fifth, refinement. Users have the optional capability to adjust the furniture's position or orientation after the placement. And last one, termination. A final decision node checks if the user wants to continue designing or exit the session. Besides that, we also have activity diagram for the technical view. So firstly, for the trigger, the process starts as soon as a user select an item from the UI catalog. And then raycasting. The system continuously casts an invisible ray from user center of guest into the physical scene. And then third, hit detection. A decision node evaluates if the ray hits the floor plan. If the user look at a wall or a ceiling, the indicator is hidden to prevent invalid placement. Fourth, real-time preview. If the ray hits the floor, the application updates the position of a preview model at those position. And fifth, confirmation and spawning. After user confirm the position of the furniture, the application will spawn the 3D model of furniture at that position. And now we approach the final section for this chapter 3, which is interface design. So the design goal for this application is prioritize clarity and minimalism. So for visibility, we will use high contrast white text to ensure good visibility. And for validation, the interface are prototyped in Figma to validate the flow before implementation. And here we have the start screen and calibration screen. So for the start screen, we will have a simple start session button with high contrast display. And in calibration mode, semi-transparent overlay use simple icon to guide user to look at the flow for scanning. And in finalization, user click finish scan to complete the setup. After setting up the application, the user will be greeted with a clear welcome screen. User click on start designing button to start the session. And next, we have the main menu for furniture catalog. It appears in a floating grid with selection of furniture. So user can use the category drop-down menu to find specific type of furniture. After choosing an item, a pop-up will appear and user can choose confirm or cancel before entering placement mode. So in this case, we will use armchair. And here we have the placement HUD and HUD interface. So we will use a minimalist HUD. The furniture catalog will then minimize to show whole room view, only showing small test status indicator here. And then we have the preview model. A ghost 3D model of the furniture will follow the user gaze on the floor for accurate positioning. And lastly, for context control, floating checkmark and cancel button appear beside the object for confirmation or cancellation. For interaction and manipulation, so this application have intuitive gesture. So user can create a pinch gesture to adjust the size, and then user make a grabbing action to select the furniture for movement. And then lastly, for repositioning, so user move the hand to update the position of the furniture placement. And lastly, rendering of the furniture model. Once confirmed by the user, the application will spawn the 3D model of the furniture in the real-world environment. So that concludes my presentation on my final year project 1 titled Home Interior Designing Application Using XR Headset. So I would like to express my gratitude to my supervisor, Dr. Tiong Wei King, for his guidance and support throughout this first phase of my project. And I would also like to thank the examiner for your time and opportunity to share my work today. And I am looking forward to your feedback and any improvement I can make on my FYP1. So once again, thank you, have a good day and goodbye.